Namaste. Welcome to my third tutorial. In this tutorial I will be explaining about the finding root of equation using Newton Raphson method. Newton Raphson method is a method of finding root of any type of equation, but this method is applicable to find only one root of the equation. It does not matter whether the equation is polynomial of any order. It can find only one root of that equation. So let me introduce it. Suppose we have f of x as our function, and we should have f of x equals 0. Finally, we need to find the root of the equation using different iterations. Suppose x0 is our initial case. Then in that case the f of x0 would not be equal to 0, so there should be some error on this root, and error is calculated using this formula, f of x0 over f dash of x0. So function divided by derivative at that case would be the error on that. So this is our initial guess, and this is error. So the first root can be found by using this formula. So even again this also may contain some error. So further we find the next error by removing some error on this x1, and so on. We get different different iterations. After nth iteration we will have the final root of the equation as xn minus this. So this is our formula for finding root of the equation. At nth attempt we can get the root of the equation. So for the proof of the formula we have here. So let yes is the error on the root, then error can be found by this formula. So after this we can get x1 equals x0 minus this, as previously I mentioned. This is the initial guess, and this is the root of the equation in our first attempt. This even may again contain some error. So this is the error on that root. So if we subtract error from that root, then we can get the root x2. Again in this way we can find xn plus 1th root as xn minus this. So this is the theory, and let us find this by using Fortran. So to write code and the Fortran, let me open terminal. For that press Ctrl Alt T to open terminal, and let us move to the folder desktop here. So I am on the desktop now. Open any editor. I will open Zini this time, and name of the file is newton.f90. To run this on the background I need to insert and here. So I will open Newton here. So you know the format of the program. So program Newton, and yes, this is the end of the program. And yes, so as I said previously, we have formula. So first of all let me make a flow chart so that you can understand it clear. So first we give input as our initial guess of the root. Then simply we can find root of the equation. Yes, for this we use not only function but also subroutine. Okay, yes, so first of all let us print please of the root of equation, and program need to read this, so read this as initial guess as x. Okay, I used x here, so I need to define it as a real variable, so I used x here, and before that let us write implicit none. Okay, so this is our reading. Now let me make a subroutine. Okay, before that let us have a function whose root is to be determined, and for that I use real function f of x. Okay, so this is the format of the function, and I use x as real variable, so I write x here, and f equals f equals, let me consider function 3x minus 1. In my previous video I did the same function on the limit 0 to 1, and we find root of that equation at 0.00, 0.3333 and so on. Okay, so this is my function. Let me define subroutine as well. Subroutine, and name of it is, let me write Newton Raphson, rap only, anti-rap, Newton Raphson, and we don't know what the function of this subroutine, so let us leave this empty right now. Okay, this is the format of the subroutine. Now we have to define various things on here as well, just like the program, as function and subroutine are almost similar on their function, but still if we need only one value, then function is used, and instead of only one value, various calculations can be done using subroutine. So that is the difference. Other things are almost similar, but this subroutine is also a subprogram, so we need to define exactly same as the program over here. So first of all, let us define some real parameter. We don't know what those parameters are, so let it be as it is, but we know the formula of root. So first let us define error equals f of x over f dash of x. Okay, and okay, so let us define this as error, so let me define error here. Okay, but I have not defined this derivative function, so let me copy this and let me define another function as well as derivative, and this is fd, and derivative of this function fd equals 3x minus 1 would be 3 only, always 3, eh? So this is our function, and this is not the function of x, it's not function of x, so let us not write anything as here. So okay, instead of doing this, let us change the function 3x square. Okay, 3x square minus 1 is our function, and its derivative should be 3 to the 6 into x, sorry, 6 into x. So this is the derivative, and to call this function on the subroutine, we need to define real external f, so f as well as its derivative as well. So to call these functions over here, I used real comma external. Okay, so I define error here. Now my root would be x equals x plus error. Okay, I already used minus here, so I am writing plus here. Okay, x minus function divided by derivative. This is our formula. Is this clear? Okay, this is root, and this x is the initial guess or previous root, and this x is the root after subtracting error from there. Okay, so yes, this is our formula, but we need to find the right root of the equation containing very less error. For that, let me define first okay, tolerance level. Tolerance equals 0.000001. so this is the order up to which this method can calculate root, and this is the order of the root. Okay, so I define tolerance here, so it's a real parameter, so I used here. Okay, this is the yes, x equals x plus if we want to find the number of times at which the Fortran found the root of the equation, then we need to define iteration as well. So I want to show that also on the program, so I define iteration as real parameter. So first of all, without using formula, there was no iteration, so iteration was 0. After using this formula one time, there should be one iteration. For that, we need to write iteration equals iteration plus 1. Okay, so whenever this formula is used by the Fortran, then iteration will be increased by 1. So there was no iteration before. After using formula one time, iteration was added by 1. Okay, so this continues. And now, so how to find the exact root of the equation? How many iterations this Fortran should do to find the exact root of the equation? For that we can define if condition. So if okay, this is the format of if, and we need to add condition over here. So if absolute value of error, okay, this is the absolute value of error. If absolute value of error is greater than tolerance, then it should do the calculation again. Okay, so this is the absolute value of error is greater than tolerance, then it should again find what error. It should again use this formula, so unless we get the error less than this value. Okay, I have set tolerance limit up to this, so the program should repeat again and again unless tolerance error is less than tolerance. Okay, so then yes, go to 10. This is the address. So again, if absolute value of error is greater than tolerance, it moved to here. It again repeats the same formula and calculation, and again iteration would be added by 1. Further this process happens unless error is less than tolerance. Okay, so this is how what this Newton Raphson method works. Now let us write print here. Tolerance is toll print tolerance, and then iteration, number of iteration, or number of repetition, number of times up to which the program calculated the true root. So iteration is iteration. Okay, this is our subroutine, and these two are our function. This is our program. So yes, we can call this subroutine inside our program to find the answer. So let us call that. Name of the subroutine is NT-Rap, and it is function of something. Okay, function, we need only two variables, yux here and iteration. Okay, so it is better to write yux and iteration only, not other variable, because we need only these two variable on our subroutine, on our program. So write down only that, yux comma iteration. Okay, so this is our call. Now we can print the root of the equation. Is yux, and number of iteration is already printed on the subroutine. So everything that the program, everything inside this subroutine is called by this, only this line. So this only these few up to number 8 we have program, and except number up to number 8, this is function, this is derivative of that function, and this is the rest of the code. Okay, so this is our Newton Raphson method, and we will be finding root of this equation, 3x square minus 1. Okay, so let us compile this. We may get some error over here, but yes, so let us compile this. Okay, end if statement. Yes, we used if here, but we did not end it, so end if is required here. Now I think there would not be error. Oh, iteration is not defined here, only yux is defined. So iteration should I have used iteration over here, but I have not defined that. So okay, still yux at 1 has no implicit type. Did I define implicit variable? No. Where is x? X should be here because I have used x, and I should define that x as real variable. So I did this. Okay, now everything is fine. So listen, our root is 3x square minus 1. So our answer should be x equals root over 1 over root under 1 over 3. That should be our answer. Let us check that whether that's correct or not. So we can give any type of guess from here. Let me give soy here, 100 here. So this is our tolerance, and in 12 times it got root of the equation at 0.577. Let us check that whether that is right or not. So root under 1 over 3 is our root, and answer is 0.5774, 5773, 50, etc. So round off would be done to get this answer. Of course, as you know that there are some errors on each methods, because these methods are derived by using I'm sorry, and these methods are derived by Taylor's expansion, and Taylor's expansion is expansion up to infinite order. But here on this method we have taken only first order, so the rest of orders are neglected, terminated. Because of that, error arises on our program. So a slightly different answer is here because of that. Okay, so this is how we can do our Newton Raphson method. See, in 12 time it got the right answer if I got 100 as our initial guess. So let us change our initial guess and let us see what happens. Okay, so let us give 1000 as our initial guess, and it will get the same answer on 15 time. Okay, so as the initial guess increases, the iteration or number of times the program does calculation will be increased. And as you know, this iteration is integer, how many times it is doing that. So we can change this iteration as not to be real but to be integer. Okay, so okay, so iteration is defined as integer. Now we can check answer of this by decreasing the initial guess. Okay, let us define minus 100 as our initial guess, and it will get root of the equation as this, because you know we have 3x square minus 1 as our function, so it has two roots. Positive, okay, this function has one positive root and one negative root, so this is getting the negative answer or next root of the equation. So this method can find both root but not simultaneously. Okay, limitation of this method is it can find only one root at the time, and we can set the limit of the error on this method. Okay, so thank you so much for watching this video, and I would like you to comment upon the errors on this code. Okay, thank you so much.